Hello, everyone, and welcome to the first normal form. Okay, in the last video, we introduced the whole concept of normalization, what it means, what it accomplishes, and a little bit about the normal forms that actually make up normalization. As we talked about, there are up to 5 normal forms, and there's a couple other forms that have acronyms to them that kind of lend itself to more normalization of a database. For the most part, 99% of the time, a database can be normalized using the first 3 normal forms. With that, that's what most people and most professionals really focus on, is those first 3 normal forms. And so for this class, that's what we'll focus on, the first, second, and third. However, what's also kind of cool is probably for the most part, 98% of everything when it comes to normalization can be accomplished through the first 2 normal forms. So those are the ones we're really going to focus on in this class, and we'll look at the third normal form, but you probably won't use it all that much, or you'll see the opportunity to use it all that much. All right? We'll make sure you understand it. Okay, one more time before we dive into this. We're not building upon everything you've done thus far. We're not going to start where you left off in regards to your design and building physical databases. The whole idea is that you've gotten pretty far. You've actually gotten pretty far in recreating a normalized database already. It's just important at this point in time, now that we got to that point, based upon our design, that we come back and we understand these rules. By doing so, later on, we'll be able to apply these rules, or at least analyze our tables that we've already created, I should say, with these rules to ensure that our database is built at its most efficient state. Does that make sense? Now, it's my belief for you to understand these rules is to understand that we need to go back a little bit, and we're just going to look at a table that probably we would never have created thus far. All right, one that's not normalized at all or hasn't been designed the way we have showed you up to this point. So we're going to go back and kind of look at this table, and we're going to then walk through the first, second, and third normal form to create a normalized database from that table. Does that make sense? Kind of bear with us. With that, go along with it, kind of do what we're doing. But again, we're not building at this point in time upon everything you've done. We will do that, okay, next week. But I feel it's very important that you understand these rules and how they apply. And I believe then when we put it all together, everything you've done thus far, along with understanding the rules of normalization, you'll understand everything. And you'll also be surprised that we now have a complete normalized database. Okay, one that has all the tables that it's actually supposed to have, and it's at peak efficiency and effectiveness in regards to how we store our data and the ability to get the data out efficiently and effectively. All right, so with that, let's dive in. All right, so for this one, a particular video, I should say, we're going to talk about the first normal form. We're going to talk about what it is. We're going to talk about how you recognize if it's not in first normal form, meaning a table. We're going to talk about what does first normal form accomplish, how to apply it, and then we'll do it ourselves and kind of show you how do we apply the rule so then you can take a shot at it through your assignments. All right, let's get going. What is the first normal form? Well, I look at this from really kind of 2 different, not different, they're relatively similar, but different ways of stating it, I should say, definitions. One being eliminate repeating groups of data from our table, or eliminating repeating columns from our table. So I don't know how you want to look at this. I need to probably look at both of them. But I guess what I mean by this is that you could just have a repeating column, and that repeating column like course 1, course 2, course 3, course 4, course 5. That's a repeating column. That's what we're trying to eliminate. Or we could have a group of data representing the course, like course 1, instructor 1, book 1, all right? And that could be repeating data. Let me get out of this for a second so I can kind of show you versus tell you. So here is a database that I created. All right, it's in Excel, but Excel is a database. It's not a relational database, but it's a database. Okay, has name, address, city, high school that the student went to, that's location, and as you can see, up to 2 courses. In this case, this is a repeating group of data. You see that? Course 1 instructor, Course 1 book 1, Course 1 book 2, Course 2, Course 2 instructor, and so on. That's a repeating group of data. If I didn't have the instructor and the book information, I had Course 1, Course 2, Course 3, that's a repeating column. With that said, first normal form is saying, I don't care if it's a group or if it's a column, we want to eliminate that and make sure it's in its own table and it becomes scalable. All right, let's get back to our PowerPoint here and get this fired up one more time. Okay, so how do you recognize it? Well, I just showed you. I don't need to kind of go through this anymore, but for the most part, once again, if you see repeating columns, repeating groups of data that represent something, with that said, that's what we're trying to eliminate. All right? What's it accomplish? Well, I think it's obvious, hopefully, at this point in time, because we've sort of done first normal form, haven't we, in a lot of ways, by going through our design way of developing a database. But with that said, as you look at this, our goal is to allow for scalability. We don't want to be limited by the amount of columns in our table, meaning if Bobby Sue took 20 courses, I only allowed for 2 courses. How are we going to handle that? I would have to go back into that table and add more columns for Bobby Sue to take 20 courses. And then if she took 21, I have to do the same thing. We don't want to intervene and keep adding columns. That would be annoying at best, right? And so we want to build a database that's scalable and that can handle a new entry for a new course that Bobby Sue took, be it if it's 1 course or 1,000,000 courses. We don't care. Okay, our database should be able to handle it without us intervening and adding more things to the database. Obviously, if we handle more things, obviously, if we add these additional columns for Bobby Sue to take more courses, maybe Bobby Niels only took 1 course. And now, if Bobby Sue took 20, I would have 19 groups of data to be nothing but spaces. That's very inefficient. We don't want to just waste space in a database for no purpose whatsoever. By doing that, we just slow the database down for nothing more than it's being sloppy. So with that said, that's another reason for first normal form. We never want to do that. Finally, if we keep these columns growing like this, our SQL statements are going to be very obnoxious too, I should say. I showed you that in the previous video. Let's pretend I have 20 columns now to hold my courses, and I want to find every student who has taken IT 101. I would have to write several OR statements, right? So if I would say where course 1 equals IT 101, or course 2 equals IT 101, all the way down to if course 20 equals IT 101. And then if Bobby Sue decides to take 20 more courses, I would have to go back and change those SQL statements. That's not what we want to do. That's not how we do this. That would be, I don't know. I'd probably change majors if I had to do it that way. So with that said, that's what first normal form is going to accomplish. Okay, it's putting our data in there efficiently so we can get it out efficiently by writing writing a query that will allow us to get the information out without concern of how many instances or how many repeating columns are there. Make sense? All right, how do we apply the rule? Well, pretty simple. We're going to create a new table with a name representing the parent table and the repeating group of data. Let me repeat that one more time. I want to kind of take you through a step-by-step approach here on applying these 3 normal forms, again, for this week. As we apply it to what we've been doing all along, things may change up a little bit. But for this week, follow what I'm doing so it kind of makes sense. So what we're going to do is we're going to create a new table. We're going to create a new table with a name representing the parent table and the repeating group of data. So we're going to kind of combine a couple words together. For example, for my student table, I'm going to create a new table. It's going to be called student, representing the parent table, and then courses. Does that make sense? All right. We're going to create a unique primary key for the new table. We're not going to stop what we've been doing thus far in that case. So in this case, it would be called INT student course ID. The new table will be a child table, and therefore will hold the foreign key representing the primary key of the parent table. So it's a one-to-many situation. We're saying for every student, they can take many courses. So based upon what we already know, wherever the many side is at, that is the child table, and that will hold the foreign key representing the primary key of the parent. Does that make sense? You should already know that. All right. We're going to move all repeating attributes to the new table. So the attributes that are repeating, we'll move them over to the new table, and then we'll delete all repeating attributes from the existing parent table. That's the steps. Does that make sense? All right, kind of that easy as we go about that. All right, so let's go ahead and apply this. Let's get to, there you go. Let's do this, right? And let's go do it ourselves so we can have a decent understanding. All right, so what I have done is create this database as you see right here. And as we can look at it, as we try to recognize it's the first normal form, we see repeating groups of data, and therefore it must be normalized. So to make this easy on ourselves and practice this a little bit, we'll go ahead and do this in Visio. And for your assignments, I want you to do the same thing. Okay? So with that said, I created already this table, or this entity, I should say. That's for students. It has the student ID as the primary key, all the way down, as you can see, those repeating groups down there. What we want to do is normalize this based upon the first normal form. So following what I just told you to do, we're going to create a brand new table. We'll go ahead and put that over here. There we go. We're going to name it based upon the parent and what the table represents. Well, the table represents courses, and so this is going to be a student courses table. All right, we'll create a unique primary key for it, and in that case, it will be student course ID. Kind of following the same rules that you already know. All right, I'm going to delete these attributes here because it's actually a little bit easier way of doing it. I'll tell you what I'm going to do. I'm going to bring this down a little bit too. And what I'm going to do is I'm going to take the repeating columns and I'm just going to move them over here. There you go. That should make it real easy for you also. Kind of makes it slick, right? All right. The next piece I told you I was going to do is create the foreign key. So I'll come over here and I'll add the attribute. Okay, so that will be student ID. All right, so this is the child table. That's the parent table, one to many, right? And let's see, I'm going to get that number off of there. I think that was part of my steps also. Get that number off of there because we're not repeating anymore. We're just going to have one instance of this group now in our table. And this is going to be course book 1 and course book 2. There you go. We come back over to our parent table and we'll delete the rest of the repeating columns. And there we go. We just made columns into rows. Pretty exciting, huh? It's fun. All right. The final thing we'll do, I don't think I had it on my list, but probably a good idea to do is, what's the relationship now between these tables? Well, it's one to many. We basically said that before, that for every student, they can take many courses, okay? And so in this case here, we'll make this a straight angle, and you can watch me try to make this look good in a few seconds. A little off, but not worth too much concern. And I'll go my begin symbol. In this case, it's going to be a 1. Okay, it's the one and only 1. And then my end symbol will be, they got to take at least a 0. We could have 0 in there, I assume. Okay, there we go. 0 or more courses. I could have a student not taking any courses yet. And there we go. That's first normal form following those rules. Makes sense, right? When you actually look at it, because you've seen this before in regards to normalization, and I'm sorry, in regards to how we designed our tables thus far. All right. Well, again, what we're going to do is we're going to make sure we analyze everything once we kind of walk through this. So now our goal is, since we're still in first normal form, is to make sure everything is in first normal form. So is our students in first normal form? The answer is yes. I'm going to get rid of that. There we go. And the answer is yes. There's no repeating columns anymore in here, is there? Okay. If I go over and look at student courses, though, there is repeating columns. Course book 1 and course book 2. That would be considered a repeating column in this case. It's not a group of data, but a repeating column. So with that said, we need to actually bring that out too. So let's do that quickly here. And I'll create a new entity here. And again, following the rules, we could call this students, bring it down the parent table, name, student, course, and then what's this going to hold? Well, that's going to be the books. All right. We would create a primary key of the same name. Okay, book ID. There we go. I'll get rid of this attribute and get rid of this attribute. I will then go ahead and move this one down. Okay, I'll go back up here and delete that one. I'm going to create the primary key. The foreign key, I should say. Hope you caught that. And that's going to be ID. All right. Some people have asked me, can I go ahead and identify the foreign key? And the absolutely yes. If you just do a right click here and set foreign key, there you go. Just that easy. Okay. And so that kind of represents that foreign key in this particular design. Kind of slick, huh? Makes it pretty easy to go with. And so we're going to get rid of that number. There you go. And finally, we'll form the relationship here. I'll make this straight. And we'll go ahead and put this here. Again, you guys can work on making these straight, but you kind of get the idea. Our begin symbol here is that for, in this case, a book can be, a student course book is going to be we can, let's see, for every course, so I just draw a blank here. So for every course, there could be 0 or more books. So that would be the end symbol. So 0 or more books. And then finally, the begin symbol for every book, there has to be at least one course. All right. And so one and only one in this case. And now when we look at our table here, I'll make this a little bit smaller. Now we're on our way to creating a database. There you go. That is first normal form. The next thing we do is look at second normal form. And I'll see you in the next video.